Hello students, today we'll see three different sorting algorithm. So sorting algorithm is uh, kind of a basic algorithm that you need for different programmings. There are two different things. One is sorting, another is searching. These are the two basic operations you probably need for any programs. So, in order to make your program efficient and in order to make your programs faster, so probably you need to implement your sorting process and searching process very efficient. So, in order to insert something, in order to delete something, you need to search something. In order to maintain data, probably you need to sort something. So if you don't have proper sorting and searching process, so you might need a lot of time to do any operations. So we have seen, some searching algorithm, linear search, and some binary search. So today we will see some sorting algorithm. These are the three basic sorting algorithm that we will introduce in this course, and you will learn a lot of sorting algorithm in your uh, following courses. So in advanced data structure and algorithm courses, you will have some advanced algorithm course. In that advanced algorithm course, you will learn several sorting algorithm, but these are the three basic sorting algorithm every computer engineer start with this sorting algorithm. So bubble sort, insertion sort, and selection sort. So they have different way to sort data. So when we talk about the sort, that means you arrange data in some order. That could be ascending, that could be descending. So bubble sort, insertion sort, selection sort, all are uh, all do sorting, all arrange data in some order, but they have different process. So uh, since they have different process, it could be possible that they might have different complexity. So in advanced sorting algorithm, they also have different process. So to sort data, probably they they have a different complexity. Let's start with the bubble sort. So bubble sort. So before coming to the algorithm, let's give some examples. So go to the slide. For examples, you have these array. You have these array. Uh, uh, in this array, you can see that 14, 33, 27, 35, 10. So it makes sense that these data are not sorted. So these are some random orders. So bubble sort does uh, check that whether the adjacent cell are ordered or not. If it is ordered, then it go for the next adjacent cells and check same things, and it does uh, same thing for the data all adjacent data. And after finishing the one turn, then it return back to the again to do the same thing. Say for examples, since this array is not sorted, so it check that 14 and 33 is sorted or not. Since 14 and 33 is sorted, this is the adjacent cell, 14 and 33. It says, so it's trying to order in ascending order. So it seems 14 and 33 is in order because 14 is smaller than 33. So they don't need to they don't need to mm, uh, actions. So they don't need to change their place. So basically what they need to do, say they need to swap. Okay, they need to swap. So if these adjacent data is not in order, then they swap data. So So for examples, then since these are the order, then it goes to the next element, so next adjacent element. Now it check that 33 and 27, since 33 and 27 is not in order, because 33 is larger than 27, what they need to do, the bubble sort swap these numbers. So you can see that this 33 and 27 is not ordered, that's why it swap. Now 27 is in the 33 place and 33 is in the 27 place. Now it checks 33 and 35, it checks 33 and 35, since 33 and 35 is in order, so it's in order, so they don't need to swap it. Then it check 35 and 10, so it check 35 and 10, since 35 and 10 not in order, then it swap. So 10 would be in the 35 place and 35 in the place of the 10. Now it finish one turns, it finish all the adjacent element, but still it's not sorted. You can see that 14, 27, 33, 10, 35, 10 is not in the right place. So what you need to do, the bubble sort start the process again, start the process again from the first adjacent start. So again it start from here. So 14 and 27 is in the right place, so they don't need to swap. Then 27 and 10, then so then it find that 27 and 33 is right in the place, they don't need to swap. Then 33 and 10 is not in the right place, then they swap, and 10 would be the here and 33 would be here. Then they check that then 35, 33 and 35, this is fine, they don't need to change. So still it's not sorted, then it start from again, then it check that 14 and 27 is the right place, but 27 and 10 is not right place, then it swap. Then finally it swap, 14 and 10 is not right place, and 10 will be here. So that means there are two kind of loop. The first loop check all the adjacent element, if it finds it's not in order, then it swap it. And the other loop, that is the outer loop, that basically restart the process again and again until this is not sorted fully. So you can see that there are two loops. Say for example, if you go to the terminals, we'll talk about the terminals later. So for examples, if you say there are two loops, so this you can consider this is one loop. We'll describe everything in details. For there are two loops, so this loop basically, the inner loop basically check all the adjacent element, and if it is not ordered, then it swap. And the first outer for loop basically restart the process. So first for loop restart the process, and it will keep restarting until the whole array is not sorted. And the inner for loop basically check all the adjacent element, if it is not in order, then it swap it. So this is the basic things of the bubble sort element. So if you go to the algorithm now, so you understand, say you can see that bubble sort that basically take a list that is not in order. There is a for loop, this element. So all element of the list, so it takes all the if list I greater than list I plus. So if it is, if the one the previous cell is greater than the following cell, then it swap it, and otherwise then it restart the bubble sort again and again until the process done with the all sorted things. So this is the idea of the bubble sort. Now let's go to the terminals. We can see the code of bubble sort. So bubble sort, so in this bubble sort process we have, say, main functions. In the main functions we take some numbers, these numbers, list of numbers, this number is not sorted, you can see that. And we call the bubble sort method, and bubble sort method pass this list, and we go to the bubble sort method, and this bubble sort method take this list or array, and then we have a two for loops. These for loops, this is outer for loop, this is inner for loop. The outer for loop you know restart the process, and the inner for loop check that if the adjacent element is ordered or not. If array of I is greater than array of k, then it's swap numbers. So what is swap number? It's just actions number. You can call, you can see the swap number definitions over there. It takes I and j and some array, then it just change the places, swap it. So if it's not in order, you swap it. So this is and restart the process again and again, and until until the whole process sort the process sort the whole array. And finally we have a print number. That print number print the array on sorted array. Let's run the programs, compile it, bubble sort and Java bubble sort. So you can see that, so we started with the unordered list, and finally we get a sorted list: 0 1 2 4 6 9 12 23 34. These are the intermediate stage of the list. You can analyze each step and find the each step each step results, and you will see that each time is proceeding, do some process and improving the list, and finally it get the sorted list. So this is the bubble sort idea. The bubble sort idea is you have two loops. The inner loop basically check whether adjacent elements are sorted or not. If it's not sorted, then it swap it. And the outer loop basically restart the process until the whole array is sorted. Now go to the so it makes sense that the bubble sort has two loops, so the complexity is a big O n square. We know that how to find out the big O n square complexity. If one loop inside another loop, then we can say that this complexity of the program is big O n square. Since we have seen our programs that it has two loops, this for loop and this for loop, and one for loop is inside another for loop. That's why that we can say that bubble sort is big O n square complexity. Now let's go to the next sorting algorithms. This is called insertion sort. Before going to algorithm, let's see the examples. So insertion sort, we have a unsorted element. The idea of the insertion sort is that you take the next element and insert that element at the right positions. So that means you take an element from the unsorted portion of the array and insert that element at the right positions in the sorted portion of the array. So you can see that imagine that the 14 is at the right place. The first element is the right place. Now you will take so 14 should be the sorted portion of the array, and all other in the unsorted portion of the array. So now we take the 33. So 33 should be at the right portion of should be inserted to the right portion of the array. So we check that what is the right portion of the 33 in the sorted portions. So what is the right position of the 33 in the sorted portions? The right position would be the after 14. So that means 33 already after 14. So it doesn't need to be changed to it doesn't need to change its positions. So 33 already at the right position, so they don't need to insert into any other place. Now let's go to the another one. So we can check that now 14 and 33 is there, then we have 14 and 33 the right position. Now we take this 27. So what is the right position for the 27? 27 right position is the in between 14 and 33. So this one is the sorted portion and this one is the unsorted portions. We take the element from the unsorted portions 27 and we find the right position in the sorted area where we can insert to the 27. So what is the right position of the 27? 27 should be the in between 14 and 33. So we change the place, 33 over here, then we have 27 over here. Now 14, 27 and 33, this is the sorted portion and this one is the unsorted portions. So we'll take the 10 and we'll find the right place for the 10 in the sorted portions. So we take the 10 and what is the 10? A right position for the 10? So right position for the 10 should be the before all of them. So what we are doing, that we shift one by one and we are making a place for 10. So 33 will be shifted over here, 10 will be over here, then 27 will be here, 10 will be over here, then finally 14 will be over here, 10 will be over here. So you can see that 10, 14, 27, 33. So then we have some more examples. You will do the same things. So you will take the 35 and 35 is the right place, and you will take the 19. 19 should be the in between 14 and 27. Then you shift one by one and make a place for 19 and you will keep the 19 over here. So the idea is that you take one element from the unsorted portions and find the right position for the element in the sorted portion of the array. So how many loop you need for this algorithm? Similarly, bubble sort, it also need two for loops. The first for loop, the first for loop, you know, uh, you know, the first for loop take the elements and insert into the find the right positions for that one, and the second loop restart the process. Second loop restart the process. The first for loop take a one element from the unsorted area and find the right place for in the sorted area, and the second loop, the outer loop, restart the process. So you can see that the inner for loop finding the right position for the element, and outer for loop restart the process. So now let's go to the algorithm. So insertion algorithm, if it is a first element, it is already sorted, so we assume that first element is already sorted. So the second step is pick the next element from the unsorted area, compare with all the element in the sorted sublist. We compare with all the sorted and shift all the element in the sorted sublist that is a greater than the value to the sorted. So we make a place for the element that we want to insert into the sorted area and insert the value and repeat until list is sorted. So this is the outer loop, and the shifting all element is a inner loop. So this is a two loop. So this is the idea of insertion sort. The main concept of insertion sort is that take an element from the unsorted area, find the right place in the sorted area of the array and insert that element in the right place. So let's go to the terminal and see some example, see some code. So we have the same things over here, the main functions. We have some array with the unsorted data, then we call some insertion sort algorithms. So insertion sort, then we have a print array to printing everything. So let's jump to the sorting portions. So you can see that there are two loops. The first one is for loop, outer loop is for loop, and inner for loop is while loop. So outer for loop restart the process, and inner for loop basically take one element from the unsorted area and shift all the elements to make the right place for the elements. So this is two loops. So move elements of array 0 to I minus 1 that are greater than key and to one position and ahead of their current positions. So we just shift all the elements, those are the greater than, for that element from greater than that element, that shift to the right side, and we make a place for the new our taken element to insert into the sorted area. So this is the insertion sort algorithm. So you can compare. So we can compile this program. You can see that the data is not sorted over here. So you can compile insertion sort and run that insertion sort. So you can see that the data is now sorted. So this is the idea of insertion sort algorithm. Let's go to the next sorting algorithm. Next sorting algorithm is selection sort. Selection sort is talking about the this guy is kind of opposite of the insertion sort. In insertion sort, we have seen that take an element and find a right position for the element to insert it. At selection sort saying that take the right element and insert at the next positions. Insertions are saying that take the next element, insert to the right positions, and selection sort says that take the right element and insert at the next positions. So selection sort basically takes some right element. So before going to algorithm, let's see some example. So for example, you have an array and this array is not sorted. You can see 14, 33, 27, 10 over here. Now what you need to do, say here is saying that take the right element, take the right element. So when you are taking the right element, we basically taking the minimum element. What is the minimum element of this array? The minimum element is 10. So what you need to do, you need to replace 14 by 10. So you are taking the right element 10 and positioning in the next position. So this is our first position. So this is our minimum element. So we are taking the minimum element at the first position and we are copying the 14 over there. Now this one is the sorted. This is already sorted. Now we have to think about only these portions. What is the smallest element in these portions? The smallest element is a 14. So what you need to do, you need to shift this 14 over here and 33 will be over here. So you can see that we are 14 and 33. We copy that 41 over here, we have 33. So now this one is a sorted. So now we have to find out the right element from there. So what is the right element? What is the minimum element over here? 19 is the minimum element of the this array. So you need to shift this right element into the next position. That this is the next position. So you have to shift 19 to over here and 27 over here. You go there, you can see that 19 and 27 and 19 will be copy over here and 27 is copy over. Now you have these portions. So what is the right position over right element for there? 27 is the smallest element. So you'll copy over there and 33 over here. So you can see 27 over here, 33. Now you have to think about these portions. What is the smallest element over here? 33 is the smallest element. So you have to shift this one over here and this one will be shifted over here. So you can see that 35 and 33. So you can make a copy 33 over here and 35 over here. Now you have to think this one. So which is the a smallest element? 35 is the smallest element. You don't need to shift because it is already at the right positions. Now you have to think about this one. 42 42 is the smallest element, 42 already at the right positions, no need to shift, and last one is 44. So the idea of selection sort is take the right element and insert at the next positions. So so how many loops are there? There are also two loops over here. The first loop, the inner loop, find the right element and insert to the next positions, and the outer loop restart the process. So this is the idea of the selection sort. Now let's go to the terminal so to see the selection sort program. So you can see that similar things we have a main functions, we call the selection sort over here. So we have an array with the random orders. There is no any sorted array. So we pass this array to the sort algorithm, and we have a print array to printing informations. So in the sort array, we see that there are two loops. The first loops that one by one move boundary of unsorted subarray basically is restart the process, and the second loop find the minimum element in the unsorted array. When they find the minimum element, then it swap with the next position element. So this one basically find the minimum element. So initially we have the minimum element, say for example first element, then we find the minimum element of the from the unsorted array. So when we find the minimum element, then we just swap with the element of the next positions in the sorted uh, next position that where we want to insert. Then after swapping, then we restart the process with the first for loop for doing the until we this first for loop, the outer for loop kept restarting the process until the whole array is sorted. Then finally you can print array and you do impressions. Let's run the programs. Java selection sort. You can see that the resulted array is sorted 11, 12, 22, 25, 64. So all the three sorting algorithm, you can see that you know if you go to the selection sort that we have discussed, I just forgot to show that algorithm. You can see that this algorithm, it find the initially it think that minimum element is the as at the index 0, then it find the minimum element in the list from the unsorted array and swap with the value at the location minimum at location min. So it basically swap the minimum element with the next position element, then increment mean to the point to the next element and repeat it until repeat. This is the outer follow that I restart the process again and again. So all three sorting algorithm basically needs two loops. So that makes sense that all three algorithm has big O n square complexity. They have the one goal. They want to sort the data in an array. So they have the different process. However, they have the different process, but all of them has big O n square complexity because they all use two for loops. So these are the basic sorting algorithm. You as I said that you will learn several sorting algorithm in futures, and they have the better versions. They are more efficient than these three sorting algorithm, since these are the these are the algorithm that depends on big O n square complexity, and big O n square complexity is not more efficient. So in order to find better efficient algorithm, probably you need to implement some other algorithm. Those are called heap sort, merge sort, or quick sort. You will learn those things in future course. So this is all about today's lectures. This is sorting algorithm. You should try different exercise. You should try implement this sorting algorithm. I will upload all this code. You will find those sorting code, my program in the resource folder. So you will find those coding in the resource folder. So you should study this code, and you should try your own to implement bubble sort, insertion sort, and selection sort. Before jumping to the code, try to do exercise and try to understand how they are, performing the operation. Try to uh, uh, clear your concept. Try to have clear concept on all three sorting algorithms. Okay, thank you very much.